Hello everyone, in this video we're going to solve the 2026 AP Precalculus Exam. Question 1. The figure shows the graph of the increasing function f on its domain -3 to 3. The function g is given by g of x equals -4.792 plus ln of x minus z. Question A. The function h is defined by h of s equals g of f of s, and this is composite function, right? Find the value of h of 2. Alright, so h of 2 is g of f of 2, right? And it's going to be g of, now f of 2, we're going to use the graph right here. F of 2 equals 5, right? So it's going to be g of 5, right? Now we're going to use the function g of s right here. So we substitute 5 for s into the function g. It's going to be -4.792 plus ln of 6 times 5 minus 6, right? It's going to be -1.614, right? Now question 2i. Find all values of s for which f of s equals 3. Alright, f of s equals 3. So we look at the function f of s right here, 3 right here, s equals 1, right? B. Find all value of s as decimal approximation for which g of s equals -1.5. Alright, so this guy is the same thing as, now we're gonna bring up the calculator. Alright, so we're gonna graph these two guys on the calculator. So go to the home screen, hit graph right here, input the first function, and then press enter. It's gonna be right here. Now the second function is -1.5. So you're gonna hit tab, input -1.5, press enter. It's gonna be right here. Alright, so you need to find the intersection right here. Just press menu, number 6, number 4. Go to the left, go to the right. It's gonna be right here, 5.48. Now question B2. Determine the behavior of the function g as s values decreases and get arbitrarily close to 1. Alright, so this guy is the same thing as, we need to find the limit of the function g of s when s approaches 1 plus, right? So it's going to be limit when s approaches 1 plus. Now the function g is right here, right? We look at the constant right here. This guy actually the vertical shift, right? So it doesn't affect this limit, right? So only this guy affect, right? So it's gonna be, now we need to find the vertical asymptote of this function, right? Vertical asymptote is where 6s minus 6 equals 0, right? And then s equals 1, right? So we're gonna grab this one, and the vertical asymptote is right here, right? So this is 1. Now 1 plus, which means on the right of the vertical asymptote, the function keeps going down to -infinity, right? So this guy equals -infinity. Now question ci. Is the function f invertible? We look at the function f right here. Alright, so using the graph to check if the function is invertible or not, we're going to use the horizontal line test, right? So we just get the horizontal line, and every single time the horizontal line intersect the given graph at most 1 point, right? So then the function is invertible, right? Now we just answer 1 right here. Yes, that's it, right? Now 2i right here, we need to explain why, right? So remember, the function is invertible if it is 1-to-1, right? And we look at the graph of the function f right here. It's gonna be strictly increasing on the domain -3 to 3, right? Therefore, every horizontal line intersect the graph at most once, right? Now we look at this one right here, f of 1 equals 3, right? And f of 2 right here equals 5, right? So different x values produce different y values, right? Hence, the function f passes the horizontal line test and is invertible, right? So now we're going to make conclusion the function f is invertible because it is strictly increasing and passes the horizontal line test, right? Now let's move on to question 2. A person purchased a car at the end of the year 2019, which is t equals 0. The car's value decreases over time. At the end of the year 2020, t equals 1. The car was valued at $27.2 thousand. At the end of the year 2025, t equals 6. The car was valued at $14.8 thousand. The value of the car can be modeled by the function v, given by v of t equals a times b raised to the t, where v of t is the value of the car in thousands of dollars at time t, and t is the number of years since the end of 2019, right? Question A, I. Use the given data to write two equations that can be used to find the values for the constant a and b in the expression for v of t, right? So at t equals 1, the cost values right here, right? So we have a times b raised to the first equals 27.2, right? And the second one, at t equals 6, the car value 14.8, right? So a times b raised to the 6 equals 14.8, right? Now, question 2i. Find the values for a and b as decimal approximations. Alright, so in order to solve for a and b, I'm going to take the first equation divided by the second equation vertically, right? So I have a b divided by a b to the 6 equals 27.2 divided by 14.8, right? Now a and a cancel out, right? So we have 1 over b to the 5th equals 27.2 divided by 14.8, right? And then we just flip this one. It's going to be b to the 5th equals 14.8 divided by 27.2, right? And we take 5th root both sides, right? So b equals 0.884, right? Now we're going to solve for a. So a equals 30.762, right? Now question B. Use the given data to find the average rate of change of the value of the car in thousands of dollars per year from t equals 1 to t equals 6 years. Alright. So remember, average rate of change equals f of b minus f of a over b minus a, right? So in this situation, we have v of a equals 1 right here, b equals 6 right here, right? So v of 6 subtract v of 1 divided by 6 subtract 1, right? Now we substitute value, v of 6 equals 14.8 right here, right? And v of 1 equals 27.2, right? Now we're going to print up the calculator. It could be negative 2.48, right? Now question 2i. Use the average rate of change found in part B(I) to estimate the value of the cost in thousands of dollars at t equals 3 years. Now this is the slope, right? We're going to use point slope formula to estimate this one, right? So we have y equals the slope right here, negative 2.48, right? Times s minus s1, right? S1 is 1, right? Right here. And then plus y1. Y1 is v of 1, right? Now y right here actually v of 3, right? So I'm going to write this one as v of 3 equals negative 2.48, right? Times 3 minus 1 plus v1, which is 27.2, right? It's right here, right? Alright, so it's gonna be $22,24,000, right? Now question 3i. The average rate of change found in part B(I) can be used to determine the secant line for the graph of v on the interval 1 to 6. Let A of t represent the estimate of the value of the cost in thousands of dollars at time t years using the secant line for A of 3 found in part B(I). It can be shown that A3 greater than V3. In general, AT greater than VT for RT, where T between 1 to 6. Use the secant line and the graph of V to explain why this is true. Now observe that the function V of t equals A times B raised to the t, where B equals 0.884, right? Which is less than 1 but greater than 0, right? So the exponential function is concave up over the entire domain, right? Therefore, the secant line connecting 2 points on the graph at t equals 1 and t equals 6 always lies above the curve for all values of t between those 2 points. Therefore, A of t greater than V of t on the interval 1 to 6, right? Now question C. When the value of the car reaches $2,000, the car's owner plans to donate it to an auto mechanic school. As a result, the car will immediately lose all of its value. Explain how this information can be used to determine a domain limitation for the model V. When the value of the car reaches $2,000, we're going to solve the equation for t, right? The equation V of t equals A times B raised to the t, where A equals 30.7 we solve above, right? And B equals 0.886, right? Raised to the t, and V of t equals 2, right? Now we put this on the calculator to solve for t, right? Press menu, number, set number 4, go to the left, go to the right. It's going to be 22.6, right? You know that the model V is no longer applicable for any time t greater than t donation, right? Because the value immediately drops to 0, creating a jump discontinuity that the continuous exponential model V of t cannot represent, right? So t must be greater than or equal to 0, less than 22.6, right? Now question 3. The figure shows a circular water wheel that rotates in a counterclockwise direction at a constant rate and completes one revolution in 10 seconds. At time t equals 0, point W on the edge of the water wheel. Point W is right here, right? Is at a height of 6 feet directly above the center of the water wheel. Alright, so this one is 6, right? The height of the point W from the horizontal line through the center of the water wheel periodically decreases and increases as the water wheel moves. The sinusoidal function h models the height of the point W from the horizontal line through the center of the water wheel in feet as a function of time t in seconds. A positive value of h of t indicates W is above the line through the center. A negative value of h of t indicates W is below the line through the center. Question A. The graph of h and its dash midline for 2 full cycles shown. 5 points F, G, J, K, and P are labeled on the graph. No scale is indicated and no axes are represented. Determine the possible coordinates t and h of t for 5 points F, G, J, K, and P, right? So, point W start from here. The midline is right here. Now first we need to find the period. It's going to be P equals time divided by number of revolution, right? So it's going to be 10 seconds divided by 1. It's going to be 10 seconds, right? Now at this point t equals 0, right? Now the first quarter is going to be right here, right? So we're going to take 10 right here. We divide by 4 because we have 4 quarters, right? It's going to be 2.5 seconds per quarter, right? So at this point right here, t equals 2.5, right? At this point right here, t equals 5, right? And then at this point right here, t equals 7.5, right? Now go back over here, t equals 10, right? So at the midline, the height is 0, right? This is the highest height, right? This is 6. Now below the midline is -6, right? So point F is the highest point, right? So it's going to be 0, 6, right? Now point G is at the midline, right? And it's going to go counterclockwise, so it should be right here. 2.5 and 0, right? Now point J is the lowest point. So the lowest point is right here. T equals 5 and the height is -6 right here, right? And point K right here, go back to the midline, which is t equals 7.5 and the height still 0, right? Right here, 7.5 and the height is 0. And the last one, go back over here, the highest point, t equals 10 and the height is 6, right? Now question B. The function h can be written in the form of h of t equals a times sine b of t plus c plus d. Find the values of constant a, b, c, and d. Now you know that the function psi of s starts at the midline, right? So the answer varies, right? You can pick this point, you can pick this point, you can pick this point, right? I'm gonna pick this point right here, right? So at point K, the vertical shift d equals 0, right? Because it starts at the midline, right? And C equals negative 7.5 because it shifts to the right, and A is the amplitude, right? Amplitude is the difference between the midline and the maximum, right? So A equals 6. And finally, B is 2 pi divided by period, which is 10, right? So B equals pi over 5, right? So when I substitute over here, we have the function h of t equals 6 sine of pi over 5 times t minus 7.5 plus 0. So we just leave it like this, right? Now question C. Refer to the graph of h in part A. The t-coordinate of j is t1 and t-coordinate of k is t2. Alright, j and k is right here. On the interval t1 to t2, which of the following is true about the function h? Alright, so either positive or negative, increasing or decreasing. We look at this one right here. Now within this interval, we see that the y-coordinate right here, negative 6 and 0 right here. So from negative 6 to 0, it could be negative, right? So the function h is negative. We need to remove a and b, right? Now, we draw the tangent line. We see that the slope of the tangent line is positive, right? Look at the Christmas tree trick. The tangent line is going this way. The slope is positive. This guy negative, right? So this guy, the slope is positive. The function is increasing, right? So the answer must be C. Question 2i. On the interval t1, t2, describe the concavity of the graph of the function h and determine whether the rate of change of the function h is increasing or decreasing. Alright, so we look at this one right here. The function h right here is concave up, right? Look, it's like this, concave up. And since the function is concave up, the rate of change is increasing, right? So we need to say the function h is concave up and the rate of change of the function h is increasing, right? Question 4. The function g and h are given by g of s equals e to the 2s and h of s equals log by 2 of 5s. Question I. Solve g of s equals 1 over e to the 6 for value of s in the domain of g. So we have e to the 2s is 1 over e to the 6, right? So e to the 2s equals e to the negative 6, right? Since both have the same base, we just equate the exponent, right? So 2s equals negative 6 and then s equals negative 3, right? Question 2i. Solve h of s equals 3. Alright, so we have log by 2 of 5s equals 3, right? Now we need to find the domain of this one. So domain is going to be 5s greater than 0, right? So s greater than 0. Keep that in mind. Alright, so we just draw the arrow right here. This guy turns out to be 5s equals 2 raised to the 3rd, right? So then it's going to be 5s equals 8 and s equals 8 divided by 5, which is greater than 0. So this guy is the solution, right? Now question B. The function j and k given by j of s and k of s right here. Write j of s as an expression of the form 7 to the expression. Alright, so we have 7 raised to the 3s plus 1 times 7 raised to the s equals 7 raised to the 3s plus 1 plus s, and it's going to be 7 raised to the 4s plus 1, right? Keep in mind, a raised to the m times a raised to the n equals a raised to the m plus n, right? Now question 2i. Rewrite KLS as an expression in which psi s appears exactly once and no other trigonometric functions involved, right? So we have k of s equals psi 2s times secant s, right? Now psi 2s equals 2 psi s times cosine s, right? Secant s equals 1 over cosine s, right? This guy and this guy cancel out, so the answer must be 2 sine s, right? Now question C. The function m is given by MLS equals tangent square of 3s. Find all input values for m in the interval 0 to pi over 2 that yield an output value of 1, right? So technically, we need to solve the equation tangent square of 3s equals 1, right? Now we're going to take square root both sides, so we have tangent of 3s equals 1 and tangent of 3s equals -1, right? 1 actually tangent of pi over 4 and tangent of 5 pi over 4, right? Alright, so we have tangent of 3s equals tangent of pi over 4. And then 3s equals pi over 4, right? Divide both sides by 3, s equals pi over 12. First solution, right? Second one, tangent of 3s equals tangent of 5 pi over 4, right? So 3s equals 5 pi over 4, and then s equals 5 pi over 12. Second solution, right? Make sure s is inside the domain right here, right? Now -1 is the same thing as tangent of 3 pi over 4 and tangent of 7 pi over 4, right? So we have tangent of 3s equals tangent of 3 pi over 4, and then 3s equals 3 pi over 4, right? S equals pi over 4, right? This is the third solution because it's inside the domain right here, right? And the last one, tangent of 3s equals tangent of 7 pi over 4, and then 3s equals 7 pi over 4, and then s equals 7 pi over 4 divided by 3. It's going to be 7 pi over 12, right? Is outside the domain which is greater than pi over 2. So this is not a solution. So we have 1, 2, and 3 solutions. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.